Well, I couldn't be more excited to be joined by the Lumai founders, Jason Guo and James Spall, CEO and CTO respectively. Welcome, guys.
Great to be here. Thank you.
Thank you, Justin.
Absolutely. Before we delve into it, would each one of you give a brief overview of your background?
So I'm Jason, a co-founder and CEO of Lumai. So my background is in engineering. I have been working on electronics, optics, and quantum physics for more than 10 years. I study quantum physics in my PhD, and then after that, then I work on optical computing, optical AI in Oxford University here. So been working on this tech for many years, 6 years ish. So now very excited to be here talking about what we are building at Lumai.
So I'm James. Great to be here alongside Xianxin. We've been working together for many, many years. We've known each other for six or 7 years now. My background is also physics, some maths and physics, and been helping Lumai over the past 3 years now, developing the optical computing technology that we spun out from our work at the University of Oxford. So yeah, great to be here. Thanks.
Absolutely. And, one of my favorite questions to ask is, was there a defining moment in each one of your lives when you knew that you wanted to become an engineer?
So for me, to be honest, I was trained as a quantum physics scientist, right, in my PhD. But because I was quite interested in understanding what quantum is, and that's why I did that. But afterwards, after I finished my PhD, decided to work on something that's more practical. And obviously, the biggest thing over the past 10 years is AI. And so to me, it's not really about doing engineering, but about doing whatever is the most important at this age. So for me, that's AI and solving the most important problem that people cares about AI, which is compute. So that's why we decided to do what we're doing here.
Yeah, and I think for myself, as with most engineers, scientists, it's about kind of the fundamentals, right? It's understanding problems, understanding why things are the way they are, and so I wouldn't pinpoint a single moment, but that's just always been the case of wanting to understand things from the fundamentals, from the first principles. And yeah, that's what we're doing at Lumai, applying those ideas, those principles to computing, to AI, understanding why compute systems are designed the way they are and how we can really redesign those to best fit the problems of today, being AI and energy consumption.
Got it. And for those unfamiliar, because you guys fairly recently came out of stealth mode, can you tell our audience what specifically Lumai is building and what you guys are working on?
Yeah, so Lumai is a spin-off from University of Oxford, and we are actually an AI processor company. We are using optics to accelerate the matrix multiplication, and to do this extremely fast, extremely energy efficient. So overall, we are building this energy efficient AI accelerator targeted for AI inference in data centers. So that's what we do.
And James, optical computing isn't a brand new concept by any stretch, and research has been done for decades around this subject, and many have tried it before and then really pivoted away. In your view, why is Lumai different? Or I'm sorry, Lumai different?
Yeah, so you're right. The idea of using optics for computing is not a new idea. And yeah, even going back to kind of 70s and 80s, people were exploring this. For me, really, the answer there is that there's now a need for it, right? There's a market and there's a need and an application being AI. And given how crazy the exponential growth in the adoption and the demands that AI is putting on our hardware today, combined with the difficulties that we're seeing in the incumbent technology, silicon and transistors on silicon chips, when you put those two things together, then suddenly the opportunities for optical computing are really obvious and really clear. So that's kind of why now, and we've seen others try this, right? We've seen others attempt kind of optical computing in slightly different ways to back in the kind of 70s and 80s, and we're doing something differently again. So really, what people have attempted is keeping this idea of silicon chips and putting optics on chip. So doing integrated photonics, and rather than doing digital transistor electronics on chip, they're doing photonics on chip. But that really is fundamentally missing it's missing the fundamental step of improving efficiency of compute, which is moving beyond silicon chips entirely. And this is really what differentiates Lumai is we're using optics in 3D space. So we're using lenses and fibers and displays and those sorts of technologies to do computing and freeing ourselves from the constraints of doing on silicon only. And that really is what sets us apart. And that's really what allows us to get to the scale that you need to outperform digital electronics.
Now, can you talk to us about some of the major trends that you guys see on the horizon and how Lumai is positioning itself to capitalize on those trends?
I think one of the most obvious trend is that right now everyone is using more and more energy. People are keen to basically buy more and more GPUs, right, to provide the required compute capability to train the models and also to do inference. And therefore, people are talking about building those gigawatt data centers and using nuclear power plants next to the data center. And everyone is talking about this. People are so keen to basically use more and more energy for AI. And then on the other hand, people are also using like liquid cooling to extract the heat, right? So I think it's very clear that everyone is so focused on the energy, but how scalable is this? So we don't think this is going to be sustainable if we are going to use 10 times, 100 times, or 1,000 times more compute for future AI in 5 or 10 years time. What do? Are we going to use like 100 to 1,000 times more energy to do that? It's clearly not feasible. So we see this as a trend. People do want more compute, but right now they are just doing the brute force way. And we want to change this. So that's why we are using optical computing, which is fundamentally more energy efficient instead of like just using more power into the data center. So that's what we want to change. We want to basically change people's mindset of computing.
Got it. Now, again, this has been tried before, and so there has to be at some point from research and academia to founding the company some key technical milestones that you've seen along the way that has got you guys energized and excited. Without giving away any trade secrets, can you guys talk a little bit about those?
Yeah, so I think really the key thing is looking at the system as a whole, right? So when we look at our optical computing technology, what we're doing with optics is just multiplying and adding numbers, right? So that's really all it is under the hood is AI is just multiplying and adding numbers, but doing it trillions of times a second. And so if you kind of naively look at the system and you say we can use optics to do that multiply and add, it can be really efficient. It basically doesn't take any energy to use optics to do that. And so that's what that's what everyone's really excited about optical computing, the potential it has. But then when you look at the system as a whole, you've got to get data in and out. You've got to convert data from digital into optics and back from optics back to digital. You've got to do memory access. You've got to do the whole system. And so really the exciting piece was even when we do the analysis of the whole system, even when we take into consideration all of those electronics and analog electronics and digital and software and everything else, we still win out against digital electronics alone. And so it's getting that realization that this technology that we have that we've been developing and researching over the past 6 years really can push on beyond what the incumbent technology is today. And again, the fundamental reason for that is breaking out of the silicon chip itself, using this kind of 3D optical technology, using the volume of space to process information means we can scale to doing the processing for free with optics whilst minimizing the overhead and energy to convert from digital to optical.
Now, have there been, when we talk about getting out of the lab and into the real world, have there been any customer engagements that have left you feeling excited or in particular that you're on the right track?
Yeah, so we have been talking to lots of our potential customers and partners. Basically, today, everyone that's buying GPUs, everyone that's using AI for example, data center deployment, etc., everyone that we spoke to like as excited as us because we focus on energy efficiency of compute, right? And as of today, basically, when you look at existing solutions, any digital solutions are basically fundamentally limited by energy, and there's just no solution for that. And therefore, the moment that we explain how our technology works and the benefit that we can bring to on the table, right? Energy efficiency, saving the cost, then people get this, and then they are very excited about what we are developing here. So that for us is a very good that gives us the confidence that we are doing the right thing for the whole industry.
Yeah, I yeah, totally agree with that. I think having those conversations and seeing the customers come to the same realization that we came to about the technology is just as exciting as kind of us having the realization in the first place, right? People understanding why this is so potentially revolutionary is really exciting.
And let's talk about the flip side. What are some of the hurdles or setbacks that you guys have experienced in the past year or two? Because getting again from the lab into the real world is a challenge, and any founder of a deep tech company will tell you it's a journey, and the journey is not just home runs along the way. What are some setbacks and what are some limitations that have kept this from getting to market thus far?
Yeah, this is a very good question. I wouldn't say we have major setbacks, but what we have realized and what we have learned over the past few years is indeed we first focus on optics, right? Because that's the critical technology that we are building. So we first focus on how we can actually deliver the optical advantages, the energy efficiency and the speed. But then after we figured it out, and then we realized, okay, there's still a whole lot we need to do to turn that into a product. We still need to develop the digital electronics. We still need to take care of the memory and the software. And it's a whole lot beyond optics. And therefore, I don't think we underestimate this, but it's just we figure out how to do optics. But that's still just the first step. And then we need to build many things around it to turn that into a product. And therefore, we did spend lots of time to build a team and also to cover all the other piece of the whole system to make sure that we have a product for instead of like just a piece of the technology. So that's what we were working very hard on over the past like 2 or 3 years to build a whole team and deliver the whole solution. And I think we are not unique, right? Any startups are the same in the journey, but it's just we will say this is lots of effort and it's very interesting.
Well, and you spoke about building a team, and it's challenging for every company of any size and market. And this time, and in this market in particular, it's true for startups in optics and photonics because you guys mentioned it. There's other companies now vying for the same market and therefore vying for a very limited pool of talent because it's an under resourced talent pool that hasn't been grown over the past couple of decades, frankly. So, can you tell us a little bit about some strategies that you guys have deployed in order to bring the top talent to Lumai?
Yeah, I think fundamentally what attracts people to a company is the technology, is the innovation that the company can offer, right? The opportunity to work on something that is genuinely novel and new and innovative, and not just to kind of step in the same direction. So a huge part of what we do, as we've mentioned, is multidisciplinary, right? It's not just optics, but it's the optoelectronics, it's the analog electronics, digital electronics, embedded software, the entire AI software stack. And so often, a lot of the people that we're attracting are not from an optics background, right? They're from a classic semiconductor background. They're from kind of large companies that are not stuck, but are not doing something quite so innovative and cutting edge. And you also get this snowball effect, right? So kind of strong teams can build strong teams. When you have people coming in saying, "Wow, you guys have got people from Meta, from Samsung, from ARM, from all these kind of big name companies," it gives them confidence, and so yeah, you get this fantastic snowballing effect, and yeah, overall we're just offering something different, right? Offering a unique opportunity to come in very early and really make a difference, and that kind of speaks for itself, really.
Yeah, absolutely. The best engineers and physicists want to work on the most interesting problems. So,
Absolutely, yeah.
Exactly.
can you tell us about some key traits or qualities that you look for in building your world class team?
Yeah, so we basically want to attract like the best people, the best engineers in the world to join us, right? So what we are doing is not like incremental changes. We are building this really disruptive optical computing technology. Therefore, we need to bring in the best people, and we need them to think out of the box, right? We would basically we use all the existing technologies in a very different way to address the compute problem. Therefore, we need people to basically excel in what they are doing, and then also think out of the box and work with a broader team, right? Our optical engineers can understand software, understand digital electronics. And similarly, our software engineers actually also know a lot about hardware, and that is very important. So all of them work very closely together as an integrated team, and everyone is very proactive, right? They don't just like optical engineers just work on optics. No, they whenever they see a problem, then they try to solve it in their own way, and that's very important because compute is a complex system challenge, and we do need everyone to work together to solve that challenge. So and finally, of course, when we hire people and we need them to be like really passionate, really believe in what we are building, and that is very critical because right, we want to attract the best people, and the best people want to work on the truly innovative, game-changing technology, and that's what we are offering, and that's what we want to do.
James, is there something that a cultural element about Lumai that somebody from the outside may not know but would find interesting?
I'm not sure about may not know, but people often assume, right, deep tech company, lots of engineers, lots of scientists, kind of heads down, hardworking. Actually, the team spirit, the wanting to work with each other and come into the office and be a part of something, really kind of shines out there. So I'm sure it's not unique to Lumai, and actually quite a lot of startups really cherish this. Is that team spirit? So we've grown. We've kind of quadrupled headcount over the last year or two. We still sit around the table together at lunch as an entire company, right? And kind of keeping that spirit of a single entity. And I think we're really proud that we've managed to keep that as we've grown the team.
And are you guys focused on growing the team locally, or is it a remote work environment?
So not locally. Right now, most of the team is still based in Oxford or in the UK, but we do have people working also in Cambridge, in Southampton, and also working in Poland, etc. And as we further grow the team, naturally we will also want to basically build a broader team working from different places because we see this what we are doing as really game changing, and we do need to bring in the talents from all over the world to join our journey.
James, what would you say to an engineer or a leader who didn't need a new job, but was curious about Lumai, to encourage them to take a look?
I would say like now is the right time to look for something innovative. We've kept saying that throughout, but really not settling for more of the same, right? So is are you really being challenged with what you're doing right now, and do you feel free to kind of challenge what others are doing? And I think that's kind of the culture that Lumai sets out, and not just wanting to chase diminishing returns, but working on something that can have real impact. And I think kind of AI as a whole is such a buzzword right now. There's an awful lot out there where you're not really making an impact with AI. And for us, the hardware is so fundamental to unlocking AI for the future, but doing it in a sustainable way, doing it in a way that means that AI can actually have positive impact rather than just burning the planet down, right? And so I think that's really the key thing is what we're working on and how we set about working on it is just really exciting.
I'm going to ask you a little bit different version of that same question, Jason. With so many companies coming out of the woodwork, and some of them showing success in the optical space, what would you say to an investor that was potentially going to invest in Lumai versus another optical company? Why should they choose you?
It's very simple, right? Because we are solving the most important, the most critical challenge of this generation, which is compute energy. And so if you think ahead in 5 or 10 years time, what do we do? Do we still stick with today's chips, which will consume say 10 times more power? How would that work, right? So that's just not going to be feasible. And other photonic companies today are mainly working on, for example, interconnect and switching, which by itself is also very important, right? It's also part of the whole puzzle, but compute is still like a very very important problem for us to solve, and that's our focus. That's what we want to do. That's what we want to change the world with what we are building now.
And each one of you might have a slightly different answer to this final question. If you could fast forward 5 years from now, what's one thing you would love for people to be talking about as far as the legacy of Lumai?
So for me, I would say in 5 or 10 years time, I would rather people don't even talk about optical computing or Lumai as doing something that's fancy, as scientific, because I hope that at that point people will say, right, of course you would use optics to do computing. Of course, why would you not do that, right? So if you now we look back, right, we have fiber communication, we use optics to do communication. Do we still think why we do that? It's so natural, right? And now we have AI, we have so many smart, say, ChatGPTs and AI coding. Do we still talk about children tests? We don't, right? It's like, it's so natural, of course. So I think in 5 or 10 years time, people would really want people to look at what we do, and they will say, yes, of course you will do optical computing because it's energy efficient. Why would you not do that?
I think a similar answer, particularly around the energy front, right? At the moment, so many of the headlines are about, oh, data centers are going to be 12% of the electricity grid, or whatever it might be, and the kind of the negative connotations around AI because of how much energy it's consuming, when actually there's so much good that can come from all these AI tools that we're developing. But so for me, it would be that thing of Lumai helped move the conversation away from AI is consuming so much energy to AI is doing good. AI is being used in a positive way because it's a sustainable technology.
Well, you guys have me energized and excited, and it's one of the reasons why, even when you were still in stealth, I was curious and championing your cause, because your desire to proliferate responsible AI is clear in both of your answers. So, really appreciate you joining us. If somebody wants to get in contact with you, how would they do that?
So they can check out our website, which is simply lumai.ai, or they can email us hello@lumai.ai.
Well, I've thoroughly enjoyed the chat. Hopefully, a year from now, we're catching up and talking about some massive wins that you've had along the way, and you'll have a cheerleader along the way, even if it's across the ocean.
Fantastic. Thank you.
Yeah, thank you.
Thank you.